Hello there, listeners, and welcome to this episode of Hacker Talks. My name is Philip, and I will be your host during today's show. If you're a frequent listener, you might have heard of an earlier discussion I had with Steve Phillip, where we talk about Docker, and he mentions Podman. Me personally, I've had a lot of experience with the pitfalls of Docker, and I went down the rabbit hole of Podman. Security is not the goal of Docker, it's never been. But what are the alternatives? Docker is being run by called the Docker daemon with sysmd. Root is needed. But what happens when the Docker daemon becomes a security threat? Podman is here to rescue. Podman is a daemon-less way to run containers and container images that makes running and testing applications a lot easier. Joining me in today's episode of Hacker Talk is one of the people behind Podman. He is a long-time Linux user, spent years working on container technology, working at Redhat for over 20 years, author of the book Podman in Action. Welcome to Hacker Talk, Daniel Walsh. How are you doing today?
Great, thanks for having me.
It's really fun to have you on the show and get to talk about Podman. But I'm interested hearing a bit about you and your background. How did you get started with Linux?
Okay, so I've been, first of all, a pretty old engineer. So I started in computing over 40 years ago. Over time, I moved into Unix world. I worked for a Digital Equipment Corporation back in the day. I ended up working on project that they had with MIT called Project Athena. And that's out of Project Athena, X Windows, Kerberos, and a whole bunch of other tools came out. I got hired into that job to actually work on porting applications to different Unixes. So Solaris, back then it was Sun OS. So I started working in Unix probably 30 something years ago. Over time, when I finally left Digital Equipment Corporation, I went to a couple of startup, and then I went to a company called BindView. What BindView wanted to do was get into the Linux market with Unix. So I worked on Unix and Linux. I always worked for this guy named Paul Cormia, who ended up coming to Redhat about 21 years ago. Don't know Paul Cormia. He's the CEO of Redhat at this point. So I followed him to Redhat 21 years ago and started working on purely on Linux here. And my background, I'm usually thought of as a security engineer. So I've been working in different security products all the way back to when I was working on Kerberos and digital equipment. Later on, I worked on sort of the first VPNs as they were coming out. We used to call them tunnels, firewalls. And then eventually when I came to Red Hat, they wanted to work on security. SE Linux was assigned to SE Linux. And then for probably the next 10 years, I worked on making SE Linux actually fairly usable. Some people might argue that. And but during the time I was working on SE Linux, I also started working on container technology spaces, different types of security. And back in 2006, 2007 timeframe, I made a thing called the SE Linux Sandbox, which was like basically the ability to set up a temporary home directory on namespace and like wrappings around it and allow you to launch things like Firefox and web different desktop applications that isolate you from the home directory. And sort of like a container, but we didn't call it a container. We called them sandboxes. Later on, I worked on OpenShift online, providing a lot of security for OpenShift, which at first was just really a huge time sharing system. We let millions of people get accounts on it, and I tried to make sure that it didn't interfere with each other. Later on, 2013 timeframe, 2012, Docker started to explode. And so I was asked to work with Docker to make it ready to be able to use enterprise Linux realm. So I worked with Docker for a few years, but I was never very happy with the design of Docker. And so I had things like SE Linux and all this stuff to Docker. But over time, we started to figure out we could do something similar. And with the advent of OCI and standardization on container images and container runtimes, we started working on our own tool chain. One of the fundamental things about my belief, the way Docker looked at the world, Docker was built originally by a bunch of basic people who were building websites out, building ways of doing. They really were into RESTful guys. And so they wanted to have basically a service and then have clients talk to the service to launch containers. That's the way they designed it. me being an operating system engineer, I grew up with the fork exec model. And so I thought that the way container should be launched is just a child of the product. So child of the program launches the container. So if you run Docker, Docker is a client-server model. So the Docker client talks to the Docker daemon launches the container. Whereas when we started building tools, I said we have to be children of the process. So when we built Podman does basically a fork and exec. It launches the container as a child of the Podman process. Because of the difference in design, it made it easier for us to move very quickly to root this mode. We started taking advantage of other parts of the operating system, like user namespace, and easy to take advantage of SE Linux, and lots and lots of security features were made much easier with, based on the fork exec model. And then we had some really bright engineers who really made running rootless containers possible. So that's where I come from. The other thing I didn't like about Docker was Docker sort of combined everything together. So basically building container images, developing containers, running containers in production. They were all used the Docker daemon. In my mind, those were different security things, right? So you have different security constraints if you're just sort of playing and developing containers, if you're building container images. But when you go to production, you really want to run tighter security. So what I wanted to do is to basically build individual tools to do each one of the tasks that they were designed to. So we split up the Docker into Podman for sort of playing and building, playing around with containers. Then building containers, we built a tool called Buildah, which can process Docker files, but we like to call them container files. And then Cryo, which was a container daemon purely for Kubernetes workloads for orchestrated containers. So and another tool we built is called Scopio, which is just really for interacting container images. So we wanted to break apart these tools and then basically develop each one of the tools with their own security models. So you might need more privileges to build it, and then running it in production, you probably want to run it as tightly secured as possible. So those are some of the ideas we came up with.
What were some of the, like you mentioned, they're getting rid of the Docker daemon, but when you guys sat down and were like, we gotta build Podman, what were like some of the top priorities?
Probably the number one priority is to make sure that everybody that learned how to use Docker will be able to use Podman. So we didn't want to set out. So there were other alternate container engines over time, like Rocket, LXC, some other tools. But when we designed Podman, we said we have to use the exact same CLI command line interface to Docker, just because we knew that Docker had, basically the mind share of the universe. So every command, sometimes we advertise Podman as just alias Docker equals Podman. Yeah. So the idea was basically if you put a volume into a container, you use -- volume. Everybody knows that. So why would Podman be any different? And in some way, in my mind, it goes back to sort of when I think Microsoft first started working on Excel. They took the prominent spreadsheet tool of that time, VisiCalc, and just copied the UI. And so in a way, we were just copying their CLI. So that was our first priority. Then, but also always looking at security. How could we do things better? How could we, because that's my background. So I really wanted to look at that. And I looked at how can we get better SE Linux support? How can we get better? We run with less capabilities. So if you don't know what a capability is, it's when you run as root, we could divide out the power of root into lower capabilities. So I wanted to question everything, but still be able to run everything that Docker can run, build container images that Docker can use. So we wanted to be fully integrated into the Docker world and the Kubernetes world, but still be able to do things more securely and without having a learning curve for users to convert over to using our tools.
And now it's fully compatible, backwards compatible with Docker.
Yeah, we have. We consider anytime we do anything that can be done with Docker that can't be done with Podman, we consider a bug. If the command line, if you use basically if you do the alias Docker was Podman and it blows up, with something like option not supported, we do it. Now, when I say that, there are a few cases where we consider bugs in Docker. And so there's a few options that Docker has sort of deprecated. For instance, --link, which they think they still support for backwards compatibility. So the things that Docker said, we're not going to do anymore. We don't do it, but also we don't do Docker Swarm because we believe that basically Kubernetes won that war. So we want to interact with Kubernetes. Now, everything I said about Podman up to this point is sort of us trying to duplicate what Docker did. But Podman stands for Pod Manager, and if you don't know what a pod is, Kubernetes has developed the concept of a pod, which is one or more containers running in the same environment. So sharing the same spaces, sharing the same security constraints, things like that. So we're developing Podman. We wanted it to be able to manage pods as well as containers. And so Podman has grown to have full pod support. And as a matter of fact, we can totally interact with Kubernetes YAML files. So if you define your application in terms of Kubernetes YAML file that can run tools like Kubernetes and OpenShift, then you can take those same Kubernetes YAML files and run directly with Podman. Yeah, so we also looked at like Docker Compose and Podman. Eventually, Podman developed not only a command line interface that matches Docker, but we also built out a on-demand service, Podman service, that services the entire Docker API. So big tools like Docker Compose and Docker PY. A lot of people built Python bindings using Docker bindings, and so we needed to be able to support those with Podman. So there's an on-demand service. I don't like to call it a daemon, since they kind of badmouth daemons a lot. But basically, we have a service that will start up when you connect to a socket, and we'll create containers based on things like Docker Compose. But that being said, Docker Compose came along many years ago, and lots and lots of people like to use it. But Kubernetes also came along. Sadly, Kubernetes and Docker Compose use two different YAML files, two different ways of defining containers, pods, I guess Kubernetes pods. So what we wanted to do is make Podman work well with Kubernetes. So not only do we support Docker Compose, but we also support Kubernetes YAML files. And we like to encourage people who've never written the Docker Compose, if they want to move into multiple containers and defining it inside of the YAML files, we'd like to convince them to use Kubernetes YAML files. Not only that, but Podman has a command, Podman generate kube, which will take your existing containers and actually generate the Kubernetes YAML files that would use those. So you could take your containers from your host to run them inside of a Kubernetes environment right away. So we're really trying to work well with Kubernetes, but not be a Kubernetes, we just want to plug into that environment with Pod. The other thing, if you go online and find old YouTube videos of my talks, I give, there was a big battle between Docker and systemd, so that Docker wanted to control all processes in the system that run in containers, and systemd wanted to control all processes. But I believe that the two should be able to work together. So when we were designing Podman, we wanted to make sure it worked really well into systemd. So there's full integration between Podman and systemd. Since Podman doesn't really have a daemon, if you want to start containers at boot time, put it into a systemd unit file and have systemd monitor and manage it. And Podman actually has tools that allow you to generate systemd unit files from existing containers. Podman runs systemd inside of containers right out of the box. So we really, again, my belief is, since we were operating system engineers, we wanted to fully integrate into the operating system as much as possible, and that includes the init system. I know there's a lot of people who, don't like systemd for whatever reason, or history, whatever, but that is the init system of Linux, and the primary init system of Linux. So we wanted to fully integrate into it with Podman.
So how does Buildah work? And how does kind of that interact with Podman?
Yeah. A critical feature in Docker was Docker build. Obviously, Docker build involved use of a Docker file, Docker file is a descriptive language for building containers images. In a lot of ways, it was what I call a poor man's bash. So there's like individual commands inside of it, including a run command. The run command would launch a container that would execute basically shell commands. When we were looking at that, I said, wouldn't it be nice if you had full bash? I felt a lot of people were always asking Docker to add bash commands to additional features of bash to Docker files. So I said, I thought that it might be really nice to have a way just to build a container image directly from shell. And so we went off and, with the same libraries, Podman is based on two low-level libraries called containers common, right? Containers storage and containers image. Container storage is the way you store images, container images on disk, and containers image is a library for pulling and pushing images from container registries. But with container storage, once we had a way of storing images on disk, it'd be really nice to just say, all right, create me a directory in container storage, and then I just start putting content in that storage, and then I run a command that says commit and create an image, and then now I could push that image to a registry. And so the tools, one of my engineers on my team, I asked him to build me a tool that could do that. And he said, oh yeah, I could do that. He said, what do you want to call it? I said, I don't care. I call it Buildah. And of course, he made fun of my Boston accent where I don't pronounce the ER sound. I pronounce it AH, and that's where Buildah comes from. But Buildah the goal with Buildah was, again, just to go out and create a directory. It has a Buildah from command, so it could pull down a image from a registry and put it into container storage. Then it would hand you back a directory, and then you could just start adding content. So you could do make install -- destinate destar equals whatever, or you could do yum install directly from your host into the directory. And you could just copy content to the directory, and then you could do a Buildah commit, and that would commit the directory and create an image, and that image then could be pushed to a registry and used directly with Docker or Podman or anything else. Of course, Buildah had to support Docker file because that was a standard way they've already built images, so we had support to build it to do that. And eventually Buildah, we needed Podman build, so Buildah is a Go library that is what's called vendored. Probably people know Go terminology, but basically it's included into Podman build. So Podman build just does container file and Docker file processing, but Buildah allows you the low-level libraries to actually build the container image any way you want for a directory. So I like to think of Buildah as being sort of a bash way of building container images, whereas Podman build is sort of traditional. I use the term container file, but it's the same as the Docker file. So that's where Buildah and Podman work together.
So something I want to touch upon is like something that's very hot when people talking about running microservices in container is overhead. How is the overhead on Podman container?
The funny thing is people ask for overhead. How much overhead is there in a container? Basically, containers are just Linux processes. You can run containers inside of virtual machines, but pretty much the way Docker and Pod run containers is by default, they just run them as standard Linux processes. So if you booted up a Linux system and took a look at PID1 systemd on your system, you would see that it's running with C groups wrapping around it. You would see that it's running inside of namespaces, and you would see that it has, security constraints on it, things like SELinux labels, exec rules, and things like that. So that's what what you would say is no container on the system runs with all those wrappings. As soon as you put a process into a container, if you looked, it's running with namespaces, it's running with C groups, it's running with systemd. They're only slightly different. So pretty much a container runs at the same speed as any other process on a Linux system. Now you can lower the amount of stuff by changing its C groups, and you could but pretty much containers and any process on Linux system have the same rights to the system out of the box as anything else. So there is no, I like to think there's no overhead to a containerized process. And now if you put them into a VM, so there are advanced runtimes, OCI runtimes, that allow you to, I think there's Kata containers, there's another one we've been experimenting, libkrun, which use KVM to isolate containers. Now those would run slower because they're running behind a KVM barrier.
Yeah, running your own hypervisor.
Yeah, right. But yeah, in general, there is no overhead to containers. That's why they're so popular.
So if someone that never touched Podman before, but they're working in a company and they have a lot of production system running with Docker, how do they get started with porting over all that to Podman?
You yum remove Docker, yum install Podman, and you run your containers. And we tell people pretty much that. And, as of RHEL 8, which came out 4 or 5 years ago, we dropped support for Docker from all of RHEL. So a lot of our customers now use Podman. But yeah, our goal was to make it as seamless as possible. Over time, there have been, I think as of this week, we got GitLab runners now running with Podman. There were certain things that would break, and certain commands that we didn't have, but we've been working on this for about 4 years now. So pretty much everybody can convert really easily from Docker to Podman, as long as they're not using Docker Swarm, which most people don't use. We continue to work on different things, and one of the interesting things that you haven't asked me about yet is Podman on non-Linux systems, which
thinking
that I'm sure they got that.
Runty and namespace that, and thinking between different namespaces, between different systems is. So if you went to Podman's GitHub site, github.com/container/Podman, and looked at its likes and did a chart on its likes, you would have seen last September, just around September 3rd or so, Docker announced that they were going to start charging for licenses to run their software on top of Macs, and I think on Windows as well. And you'd see a steady chain of likes, and then all of a sudden on that day, there's a huge spike and everybody coming in looking for Podman. And so people were looking for an alternative for Docker on Macs and Windows. And we've been working on, we're working on it at that point, but we weren't quite ready for prime time. So we got, but lots and lots of people started using it. The demand skyrocketed. So over the next few months, we made the experience better and better. And now pretty much everybody, anybody that wants to run Podman on a Mac or a Windows box could simply just install Podman. Go on it. You can go to podman.io to find out how to do that. But Podman now, we added what we call Podman machine. Anybody that runs Podman and Docker run Linux containers. And so in order if you're using Docker desktop or Podman desktop on a Mac or a Windows machine, you actually have to have a virtual machine running somewhere where basically there's a client in your Mac that's talking to a Podman service or a Docker daemon inside of the VM. So on a Mac, we did Podman machine, which basically sucks down a QEMU. Actually, it's a Fedora CoreOS image with Podman installed, and it starts communicating with Podman inside of the virtual machine. But from a person sitting on a Mac, it feels just like you're running native Podman. On a Windows box, we actually do with WSL2, which is a Windows subsystem for Linux, which really is just a VM as well. It's just Microsoft has done a really nice job of embedding virtualization, Linux virtualization into their platform. So we're taking advantage of that on Windows. So one thing we didn't have till very recently was a GUI wrapping around Podman. And so there is a Podman desktop effort that's going on right now. It hasn't been fully released yet, but you can get daily release in the open source community, daily releases of it.
So if you go to GitHub containers/Podman desktop, you can get that. That's a full GUI that shows you the containers running, allows you to manage the machine. Runs on Windows, Linux, and Macintosh. Again, we want to provide an alternative to Docker for people who just want to run on, people who sadly have to run on a Mac or Windows, don't have the pleasure like I do of running Fedora on my laptop. So yeah, we're still waiting for the Linux to take over the desktop, but it took over my desktop about 20 years ago. I would never use anything else. Some people like Macs and Windows. I don't know if you've heard.
I read somewhere that next year is going to be the year of the Linux desktop.
Exactly. It turned out it was the year of the Linux cell phone, maybe. Yeah, so with the Android, but never had the year of the desktop.
So you mentioned that you have been at Red Hat for a while, been fiddling with security. How do you feel like the Linux, security mitigations have changed on the operating system level?
It's funny because I was just looking at new ones. There's I meant to block you with the name of it. What's it called? Anyways, I've been investigating different parts of, it'll come to me in a second. I've been investigating different parts of Linux security for years, Linux capabilities. So SecComp is a way of limiting the amount of syscalls that a process can have. Obviously, I've worked with SE Linux. I haven't worked too much with AppArmor because it's sort of a competitor to SE Linux and runs on Ubuntu. I usually work on Red Hat, Fedora, Red Hat-based projects, but I'm familiar enough with AppArmor to understand how that works. And then user namespace has been a huge advantage. So user namespaces allows you to do root type things without being root on a system. So you can run, that's how we run rootless containers, is taking advantage of user namespace. And there's other things, other subsystems that are coming into Linux all the time to provide additional services. Basically allow you to secure your system. And, so one of my jobs as I'm looking at these tools is to figure out, which ones we can take advantage of as we run containers and try to work them as securely as possible. And the one that I was thinking of just came to my mind. It was called Landlock. So Landlock just got merged into the Linux kernel. And what Landlock allows you to do is, as I understand it, is to specify a directory, and then you can specify whether or not your processes or your children processes can read and write to that directory only. So for instance, one of the things we're looking at when pulling down and installing images is lots of attacks where someone might give you a screwed up tarball that could attack your system. So we're looking at Landlock as being a potentially another wrapper where we could say, we only want you installing this package into this directory, not anywhere else on the system, and try to lock down stuff. But so those types of mandatory access control, discretionary access control systems, anything that comes out on Linux, I'm always investigating to say, hey, how can we take advantage of this in containers to make it more, to make containers more secure?
Has it always been? You mentioned earlier it's been Unix as well, but has it always been Linux?
I worked with BSDs a few years ago, but a little bit. But I mean, I've been a Red Hat for 21 years at this point. So I did work with SunOS, Solaris, Ultrix, AIX, HPUX. So I've handled most of the different Linux, even IRIX back in the day. But the nice thing is, back when I first started on Linux, it was always about, how does it work on this Linux versus this Linux, and trying to convert it around. And pretty much the world settled on Linux, although FreeBSD is still out there. And actually, we've been working with a FreeBSD person over the last few weeks, and he's gotten Buildah, and he's close to getting Podman to work with Linux jails on FreeBSD jails. And so you'll see Podman and Buildah and those tools all working on FreeBSD, probably fairly soon. That's the beauty of open source, is that if contributors want to work on stuff like that, they can do it.
That's true. So do you have any, like you said that you work with SE Linux, do you have any best practices for implementing SE Linux?
It's funny. So I worked in SE Linux for 10 or 12 years and just started into containers. And one of the key problems with SE Linux wasn't a problem with SE Linux, it was a problem with Linux, in that if SE Linux is all about controlling the way two processes communicate together. And so what SE Linux has to do is define allowable routes that these processes can interact, that process and file systems can interact. And because of that, it was always causing issues with people, because in Linux, you can have processes communicating in 10, 12, 15 different ways. So for instance, if you think about, say, a web service, right? So I want to confine my processes, say CGI scripts inside a web service. Well, I can put content for a web service anywhere in the Linux system. And so all of a sudden I put my content into a /op/var directory. And then SE Linux says, no, that container process, that web browser is not allowed to read it there. And so it blows up. And someone has to figure out, I have to change the labels on the content, right? So it'll work. And the funny thing is, when that blows up in discretionary access control, say that the Apache process is not allowed to read content, people just chosen it and they felt that's okay. But when they came to SE Linux, it was like, no, that's too hard to figure out. But other things were like MariaDB, the Apache service could talk to a database via Unix domain sockets, via shared memory segments, via and like SE Linux be constantly trying to block the communications. So it became it's difficult because of that, because of the flexibility of Linux. It's difficult for people to understand why SE Linux blocks it. But basically, SE Linux is saying, you're going to tell me how you want this to communicate, and you can set them up to communicate. So because of that, SE Linux was difficult to use on a general purpose Linux operating system. As soon as you take your applications, instead of having a general purpose installed anywhere in the system and communicating anywhere, and you stick them inside of a container, all of a sudden SE Linux can basically wrap that container in such a way that says, I like to say, what goes on in the container, what happens in the container happens in anything you want to do in a container, it stays in the container, and if it tries to get out, it breaks it. And I talked about cell phones a little while ago. Android a couple of years ago turned on SE Linux. So all the Android systems in the world right now run with SE Linux in enforcing mode, and nobody knows about it. And the reason they do that is because they're running containers. They call them applications, but basically an application on Android box is nothing more than a container. So as we move to containers and in Linux, basically it's the same thing, that we can put up all of our applications and boxes, and then SE Linux makes sure that they don't break out via file system. Most of the breakouts that happened in Docker over the years have been file system breakouts, and almost every single one of them was blocked by SE Linux. So SE Linux is a great tool for controlling containers, and it becomes really easy. The only time SE Linux causes issues with containers is on volumes. So, because again, you're taking something from outside of the operating system and sticking into a container. And what we've added to Docker and to SE Linux, which is the colon lowercase z or z, as the Europeans like to say, and our uppercase z, which allows you to, tells Podman or Docker will relabel the content to match the labels inside the container. And that's, so people have a much easier time with SE Linux in a container. All of, Kubernetes works with it, OpenShift works with it. So SE Linux is a really key tool to keeping containers inside of the container, not allowing them to get file system escapes from containers, but doesn't interfere with what's going on in the container. And then lastly, since containers are designed to communicate over networks, right? So you don't have to worry about your Apache server talking to MariaDB, MySQL server. The only way they're allowed to connect is through the network. They're not allowed to connect through random files or random domain sockets and things like that. So SE Linux just allows network communications. It relies on IP tables and other tools to control network communications. So SE Linux doesn't get in the way of two containerized processes
So has there been any major security bugs that users have found in Podman? Like privilege escalations or...
There are CVEs that show up once in a while. Usually the CVEs show up. If a CVE comes out, it's almost guaranteed to be across the board. So we've had CVEs in Podman, Docker, Kubernetes earlier. Luckily, most of those have been blocked by SE Linux. Sometimes there's CVE, most of the container tools, including the ones I just mentioned, are all written in Golang. So sometimes there's CVEs and the Go compiler, and so we suffer from those. But there's the major breakouts that people would look at for container breakouts. Again, they've all been file system. I think for the most part, they've all been file system breakouts, and SE Linux has blocked those. But usually, what I usually tell people is keep the systems up to date as much as possible, because as soon as the CVE is discovered, we jump through hoops to make sure we get releases out, especially in the Linux world, in RHEL world, Red Hat Enterprise Linux. We backport fixes to ancient versions of tools to make sure that anybody running older versions is updated as these come out. But again, if you're running a containers rootless mode, then they could break out and attack your home directory, but they don't have full root of the system. User namespaces wrap around it. SE Linux wraps around seccomp fools, drop capabilities. So we try to wrap as much as possible. I'm also looking at, so it's going towards the future. I've actually been moving over to a little more towards what's called edge devices, and looking at how we can use tools like Podman to run on the edge. And so we've been concentrating on different security at the edge. And there's a few things that you want on the edge. One is you need to, if you have thousands and thousands of boxes, you don't necessarily have a tool like Kubernetes to go out and interact with thousands of boxes. It's not really what Kubernetes was designed for. And edge devices, say you had, 1 million windmills, and each one of those has a computer on it, right? You need those things to sort of phone home to get updates. And but we believe the future is that those updates are going to come from as containers, containerized images. So we're looking at how can we make Podman really work well in those type of environments. So in the future, we're looking at that, and that's one of the reasons we want to push for Kubernetes YAML files. Is imagine you're running your apps. You want to run your apps in the CI/CD system. You want to build it potentially with Kubernetes and run all your test suites with Kubernetes. Now you put it out to the field, and you really want to run Kubernetes. You want to run that Kubernetes YAML, basically the same descriptor for your application at each one of the windmills, but you don't really want the overhead of a Kubernetes service run. So we want Podman on a service running under systemd to be running on these edge devices. But going towards the future, an edge device is basically a computer that can be touched by untrusted people. So most people, when they look at data centers, you probably trust your sysadmins, right? So either inside of your company, or if you're outsourcing to Microsoft or Amazon or IBM Cloud or Google Cloud, you probably somewhat trust the administrators there to do the right thing. But as soon as you put your computer onto something in the public, then theoretically somebody can, a hacker can come up and touch the box, right? And so
there's web cameras. There's not a note that's always there at the data centers and checking.
Right. Yeah, there's no lock on the door or anything. And in my opinion, as soon as I can touch a computer, I can probably figure out a way to hack into it and become root on the computer. So that's, it's an interesting problem. But there's a solution coming along called confidential computing, which is kind of interesting that it allows you to run encrypted virtual machines or encrypted containers. So imagine in the future you have a small box, and when it boots up, there's all sorts of measurements of the software in the box, and at a certain point, the box is going to run a tool like Podman, and Podman is going to have to communicate with the remote server and say, this is how I booted, and the service is going to look at that checksum and figure out whether or not the machine's been hacked at all. If it hasn't been hacked, it will start downloading software onto the box, and that software will be run in encrypted mode in such a way that the root on the box will not be able to look at what's going on inside of the container. And then you can download your data to the box. And that's taking advantage of new chips that are coming out of, there's ARM chips, there's AMD chips, and Intel's working on similar technologies.
It's the Intel SGX.
SGX stuff, yeah. Yeah, and that now can run with full virtual machines. So you can run, a lot of this is, you have to have really big, powerful boxes. It's not in the mainstream boxes yet, but so you can run these full virtual machines or full virtualized KVM separated containers in encrypted mode. And so I think within 2 years, that'll become more prevalent and we get down to cheap boxes or cheap, to laptops and things like that. And you'll be able to start running encrypted workloads. So now, if you have your edge devices, where you have probably surplus CPUs, you could start to run these encrypted workloads. And now if someone does hack your box and you had secret data on it that you didn't want someone getting a hold of, it's all encrypted. And even root on the box, root could do a denial of service at that point, but he can't, he can't get access to the data that say Windows was working. Similarly, if you had 2 or 3 containers running out of box and one of the containers did have an exploit that got out to the box, the other containers would all be encrypted with different encryption than the primary. So they wouldn't be able to attack each other. So that's sort of the next big jump, in my opinion, in computer security is going to. Now, I don't know if this will take off in the cloud because it's expensive to run this way. So your cloud is all about squeezing as many containers on a system I want
to run the Intel SGX stuff and play stuff.
But for edge devices, it could be an interesting use case for it anyway. So, that's what I'm looking for.
Play devil's advocate here. Isn't all Intel SGX stuff all proprietary software by Intel?
Well,
how can we audit that?
We can. But you can't audit anything Intel does. So, it's not. This is not a new problem. But I mean, they're providing services. Again, at a certain point, we have to trust the computer system that we're running on, the physical hardware. Back in the day, when I used to work with different government agencies, they'd always be worried about, where was the stuff manufactured? If it's manufactured in, hostile countries to the U.S., how can we trust it? And you can't. It's like, I don't know. It's a tough problem, right? But manufacturing these things inside the United States is way too expensive. So it's catch-22. But anyways, if we trust Intel and AMD to do the right thing, then you can get greater levels of computer security by using encryption for processes in such a way that administrators on a machine, people who have hacked into a machine, be able to see what's going on.
I have an interesting question here. If you were supposed to put up a Podman container that's internet facing, how would you do that? Or if you were to put up a service that's internet facing, what kind of security mitigation would you put in place?
Well, pretty much we run with everything by default, fairly secure. So it's running with SE Linux. I would. There's a flag in. It's funny. I have a debate with another engineer on my team, but I would run with there's a flag called -- user namespace equals auto. And what this does is it picks out a random user namespace to run your containers with that is isolated from all other UIDs on the system. So it will pick out, 1,000 or 2,000 or 3,000, whatever number of UIDs your container needs. And then we'll run each one of those isolated. So you can run 100 different containers in your box. Each one of them would have separate UIDs. So you'd be able to take advantage of isolated user namespace. From a networking point of view, I would probably run it in Podman has a really nice new network stack called Netabark. And you could set up private networks to sort of isolate, and then you could fool around a little bit more with IP tables rules and really try to control what processes inside of the container. We have some open source engineers who are fooling around with running containers that have no networking, but you can actually use socket activation, and you could have a container that has no networking at all, but it will answer TCP connections. So it can work with the TCP connection, communicating back, but it wouldn't. So if you think about you have an Apache web service, and you want the Apache web service to answer connections, but not be able to attack other systems. So you can actually, with namespace manipulation, network namespace manipulation, set up containers that have very limited network access. So there's some really tight tools you can do, but you really have to understand how your application works in those. But out of the box, it's just, I would run always with the user namespace, so you're not running as root inside of containers, real root inside of the containers. And this is something that's very difficult to do with Docker, but very easy with Podman. I would run with SC Linux in enforcing mode. You run with as tight as SecOp rules as possible, and run without root inside of my container if at all possible. So, rootless container where if I became root inside the container, I'm still not root on the host, but even run it without root inside the container. So lock it down as much as possible. And pretty much most software will actually run in that mode. It's just people don't understand that.
How has the user adoption of Podman?
So, a lot of times I like to describe Podman as the Pepsi to Docker's Coke. But some people might say we're not quite that level yet. But to give you an idea of GitHub statistics, is 1.5 thousand people have forked it. There's nearly 15,000 people have liked it, started it. So this, I would say it's pretty damn popular. I think if you went on Twitter right now and said, what's an alternative to Docker? Get Podman. There's lots and lots of conversations on Podman. It's everywhere. So, it's not up to Docker level. It's not the dominant name, but I would say there's thousands and thousands of people using Podman in the world. And as I said, from Red Hat's point of view, if you're using a Red Hat operating system, that's what we tell people to use for running containers. So it's pretty popular. And I do a talk. I'm doing a talk in New York next week where I show that Podman, from a developer point of view, has more pull requests, more commits, much more active community than Docker does at this point. And lots and lots of new features are going into Podman. So Docker's kind of slowed down as far as its community contributions is concerned, and Podman's just taking off. So
that's awesome.
Yeah. But I have nothing against Docker. I don't want to come out. No. We're both open source projects. It's just we wanted to have an alternative to Docker available for people.
Absolutely. It's
one interesting thing we have right now. So we have methods that are fully OCI compliant to speed up pulling and pushing of images from container registries. Traditional. This gets a little too technical probably for someone on your podcast, but the new standard for the containers are stored as tar format, tar archives. And when Docker created it, first started using it, they used gzip for compressing. So we store those compressed. Well, ZSTD, it's ZSTD, is the new sort of popular standard for compression algorithms. And so we have a couple of real smart engineers on our team that have worked on not only converting to use it ZSTD for the storing of OCI images, but also has figured out ways to pull only, basically you can look at all the files that you have in your current storage and only pull down the files that are different, reassemble the tarballs on the fly. So we can pull down much less of an image and do it very, very quickly. The problem is that right. You see, it's like sort of like RPM diffs, but in our case, these are at the file level, not at diff level. But anyways, it's really, really fast, really, really impressive. But the problem is old Docker clients don't support it yet. So even though it's fully compliant with the standard, it's just, so we have to wait till Docker gets newer versions out in order for us to start taking advantage of this really big advancement and usability of our tool, because we want to remain compliant, so that we don't want people, creating images with Podman that can't be used with Docker. So we have to make sure that both tools work together at all times. But because of that, we're somewhat hindered waiting for the older versions of Docker to sort of age out to newer versions of Docker to replace them before we start, building new and better images that can be shared by both tools.
Is Podman mostly Go now?
Yeah, it's all written in Go. A lot of libraries, a lot of low-level functions are actually shared between Docker and Podman. There's libraries like runc, Kubernetes libraries there's libraries up and down the cloud native world that our tools are all taking care of and taking advantage of, and they're all written in Go. So pretty much almost everything in Podman is written in Go, but it's network stack. So we wrote a brand new network stack that's using separate programs. So those were written. My team wanted to write it in Rust. So we have a sweet retired network stack. So there's a network daemon that configures the network stack, and then there's a DNS daemon just for sharing DNS between the containers, and that's all written in Rust. I tell my engineers I'm too old to learn Rust, so I let them go off and play in Rust. But the rest of it's written in most of it's written in Go. Some obviously the Python code, those libraries is a Podman Python library, the Docker Py, Docker Compose. Those are usually written in Python, and then obviously we support Bash tools like that are in there at some point. But pretty much, I would say 95% of all the code's written in Golang.
What do you personally prefer programming?
I guess Golang now, because I've been doing it for about 10 years. So I used to love Python ever since Docker came along. Docker was started 10 years ago, or more than 10 years ago. Now it's probably close to 13 years ago. But before I read in C, in Python, I did a hell of a lot of Python over the years. So those are like my preferred languages. I always tell people I learned how to program in Java and C++ probably 20 times in my career, and then forgotten it over time. So, but pretty much everything is Golang at this point. Golang in C, a little bit of Python.
Yeah, I hear so many good things about Golang, and it's very effective. And
well, Golang, the nice thing about Golang is it's easy to learn. If you know C programming, or that world that translated to Go, it's fairly easy. I guarantee if you never programmed Go, but C, you could, by the end of the day, you could be writing decent Golang programs. It's fairly easy to pick up. Whereas Rust to me looks totally foreign. So,
but I think Rust more like C++, where you actually have to think about the pointer and the allocation and all that. So, Daniel, thank you for coming on Hacker Talk. Is there anything I've forgotten to ask you, or anything you want to jump deep?
Well, no, I think 1 hour is probably enough for people to listen to me. But there are talks. If you go onto YouTube and look for Dan Walsh and containers, you'll find all sorts of YouTube talks that I've given over the years. I go deep into what's the difference between a container and a VM from a security point of view. So some of those talks are always interesting to people. I've done a bunch of coloring books, and now you can get, I'll shamelessly plug my book. So if you go look for Podman in Action. So there's it's not fully out yet. You can get access to it. So it's Manning Publishing, and it's called, Manning offers this thing called Manning Early Access Program. So you can get not physical books, but access to the book online. I actually finished with my editor last night because we basically signed off on the final, but now it goes into production editing, I guess, which could take another month or two. I think by September 1st, it should be fully. I'll get a physical book in my hand, which will make me very happy, because writing a book is a difficult process, but it's very satisfying when it's finally when you finally have a physical thing.
How long it has been?
So I started working on it last September. So actually right around the time the Docker announced that we're charging for access to the Docker on Mac. That's when I started working on it. Worked probably 10 hours a week for about 8 or 9 months. So it took a while, but writing, I write a lot on blogs and things like that, but those are usually 2 or 3 pages. This writing 300 or so pages on a book is a little more difficult.
What's your writing process? I know when I do larger articles, or I've been editor for a book, and I just write mind maps, and then I pick up topics and write about everything. Do you have some kind of?
So usually I actually started blogging probably 15, 16 years ago. And I didn't have as organized a process in that, but I get lots and lots of emails, and people would ask me a question, and I'd start replying to the question. And then I'd say, if I reply to one person, I'll end up having to reply to another. So I decided many years ago that they ask me a question, I'll write it as a blog and then send them a link to the blog, and then everybody can get it. So that's how I wrote a lot of my content. And when I came to writing the book, I mapped out all the chapters and the topics I wanted to cover. Then I went up to my existing blogs that were out there and started pulling them in and expanding those, adding pictures and things like that. But pretty much, if you want me to write a blog, ask me a question via email, and then so that triggers me to go off and write a couple of pages. And again, it was more about, I don't want to answer these questions once. I want, everybody I want them to find it via Google. So I've been writing hundreds, maybe 1,000 articles over the years. I've read a lot of articles, and then just doing a book is just being disciplined enough to get them, basically to take existing content, rewrite it, and put it into book format. That was my thinking. Then the editors wanted it to do it more as a teaching format. So then I had to sort of change my mind, change the way the content was provided into, sort of do this and then explain what to do. So that was interesting. If you read the book, the first 8 or 9 chapters are really about Podman, and the last 2 really dig deep into container security. That's sort of what my real expertise is. So the last 2 chapters of the book will probably overwhelm most people, but it's everything I know about container security. So it goes deep into things like Linux and all that stuff. So hopefully people enjoy it.
And where can they find your book?
It's at Manning.com. So if you go to Manning.com and look for Podman in action, or if you just type in the Google search or Bing search, Podman in action, it'll take you right to the website. Download it. I think a month from now, once there's physical copies, it'll be available on Amazon, I'm sure. So right now it's just in the access program.
Awesome. I'm looking forward to that. We'll have that link in the show. It was a pleasure to have you on, and I hope to have you on in the future as well.
Nice to meet you.
To all our listeners, thank you for tuning in. Have a good one. I'll see you in the future.